Today we're going to talk about the law of cosines. And the law of cosines applies when we cannot use the law of sines to solve an oblique triangle. So those are two cases. If we know side, 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 so three sides of a triangle. If you imagine, we know sides A, side B, and side C. That would not allow us to do a law of sines because we have no angle side match to set up our proportion. Also, if we knew side, angle, side, so we knew something like angle A and sides B and C. Once again, we couldn't figure out either of the other two angles, and we have no angle side match to start our proportion for law of sines. So we need something else, and what we need is called the law of cosines. The law of cosines has 6 different ways it's expressed, but 3 of them are in a pattern, and the other 3 are in a pattern. So this first pattern looks a little like the Pythagorean theorem, except since it's not right triangles, there's something taken away. So we have c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. And if you needed to find side B, you could do b squared equals a squared plus c squared minus 2ac cosine of angle B. And if you wanted to find side A, you would do b squared plus c squared minus 2bc cosine of angle A. So those are the 3 formulas for finding the sides of the triangle. But in order to use them, you'd have to know one of the angles and the 2 sides that sort of make up that angle. In other words, you'd be in the side angle side case. The others are for finding angles. So if you were in the side, side, side case and you needed angles, the cosine of angle A is b squared plus c squared minus a squared over 2bc. The cosine of angle B is a squared plus c squared minus b squared over 2ac. And the cosine of angle C would be a squared plus b squared minus c squared over 2ab. One note about using this, because your calculator writes everything horizontally, it's best to remember these formulas with parentheses around the numerator and parentheses around the denominator so that the calculator gets them right. Okay, otherwise we're going to have problems. Okay, so let's try a problem. Let's suppose we know that angle B is 58 degrees, side A is 12, and side C is 20. So we're not in any position to do the law of sines, so we're going to do the law of cosines. And the one we want is the one that says side B squared is equal to a squared plus c squared minus 2ac cosine of angle B. So what I'm going to type into my calculator is 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 58 degrees. And when I punch that into my calculator, I get 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 58 degrees. Now, remember, that's b squared, so I need the square root of my answer, And that tells me it's about 17.02. Okay. Now I can go after angle A. And some people say when I do a law of cosines problem, I like to stick to the law of cosines. And I'm going to do that in this video, although it is possible to switch to the law of sines if you can hold on to that rounded value. So if I were to find angle A using the law of cosines, I would say cosine of A is equal to B squared, so that's 17.02 blah 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 squared, plus C squared, 20 squared, minus A squared, 12 squared. I'd make sure I put that in a parenthesis. Divided by, in a parenthesis, 2 times 17.02 times 20. Okay, so how would that look on my calculator? I'm going to open a parenthesis. And I'm going to have answer squared, right, because that's that number, plus 20 squared minus 12 squared, close that parenthesis, divided by, open parenthesis, 2 times my answer times 20. Okay, and that's the cosine of A. So I'm going to do inverse cosine of my answer, and that gives me about 36.72 degrees, approximately 36.72 degrees. And now I'm just going to do 180 minus 58 minus 36.72. So 180 minus 36 minus my answer. And I get about 107.28 degrees. Feel pretty good about that because the small side and the small angle, the medium side and the medium angle, and the big side and the big angle. So let's try it one more time. Suppose we know 3 sides. Then I'm going to use my law of cosines because I can't use my law of sines. And let's say the cosine of angle A is going to be, in a parenthesis, 9 squared plus 13 squared minus 15 squared. That's B squared plus C squared minus A squared over 2 times 9 times 13. Okay? Figure this one out. In a parenthesis, I have 9 squared plus 13 squared minus 15 squared divided by 2 times 9 times 13. Okay, that's the cosine of angle A. So angle A is about 83.87 degrees. Okay, we're going to find angle B. The cosine of angle B is 15 squared plus 13 squared minus 9 squared over 2 times 15 times 13, which actually I should use times signs because I'm going to put that in a parenthesis. Okay. So 15 squared plus 13 squared minus 9 squared divided by 2 times 3 times 15 times 13. And that's the cosine of angle B. So second cosine, second answer. About 36.62. And I could have been very, very precise in finding angle C if I had stored angle A. And I could be really, really precise about finding angle C if I do another law of cosines. But I think I still have the numbers on my calculator, so I can type numbers in. So I've got 180 minus 83.8669, that ought to be enough, minus my answer, which was the 36.624. And I get 59.51 degrees. What was that again? 59.51. Okay, so that's how we use the law of cosines. Remember, it comes in two flavors. It comes in this flavor, which is for finding angles, and it also comes in this flavor for finding sides. And we use it, it's more complicated, so we only use it when we can't use law of sines. I hope this works for you.